310 million years ago, Earth belonged to the giant insects. Dragonflies with 28-inch wingspans patrolled the skies like armored eagles hunting. Scorpions, the length of a human arm, lurked in the humid shadows. Centipedes, larger than alligators, crawled between fallen trunks of ancient, primordial trees. You wouldn't last an hour there. This was the empire of exoskeleton, giants, and nothing escaped them. Ever. For more than 150 million years, they reigned absolutely unchallenged. Perfect evolutionary machines molded for a planet that would never exist again. But then the empire fell. Some shrank until they became silent echoes of what they once were. Others vanished completely, leaving only fossilized traces of their lost grandeur forever. For decades, scientists believed they had solved the mystery. Atmospheric oxygen. Simple. The air changed. The titans disappeared. Until researchers from the University of California examined more than 10,000 fossils. 320 million years of evolutionary history. Fossil by fossil. And they discovered something deeply disturbing. It wasn't natural extinction. It was systematic elimination. What annihilated the giants wasn't climate change. It wasn't lack of oxygen. It was something that started hunting each one of them. Something fast, relentless, and totally unexpected for scientists. But before you meet the killer, you need to understand how these monsters arose in the first place. Because the secret is hidden in the very air that they breathed. Rewind 350 million years, the Carboniferous period, a unique era. It wasn't just an era marked in paleontology textbooks about ancient life. It was a chemical conspiracy orchestrated by life itself on planet Earth. Colossal forests of lycophytes stretched across entire continents, covering the planet's surface. These giant plants reached 130 feet in height, covering endless swamps everywhere across the ancient world. But here's the fascinating detail. They weren't real trees at all. They were distant evolutionary relatives of the mosses you see today in parks. Swollen and monstrous versions fed by an absurd abundance of natural resources. And when these plants died, nature's perverse trick happened right then there. They didn't rot. They simply didn't rot. There were no bacteria capable of breaking down lignin, the resistant compound that forms plant structure and walls. So the trunks sank into swamps, piling up layer upon layer over millions of years without decomposing ever. Carbon trapped underground forever and ever. What would one day transform into the massive coal deposits that fueled the human industrial revolution centuries later? Meanwhile, oxygen accumulated in the atmosphere without any control at all, increasing 25%, 30%, 35%. A concentration so extreme that a single spark ignited entire forests instantly. Even waterlogged wood caught fire spontaneously. And in this super-oxygenated world, physics favored the exoskeleton giants completely, absolutely. Meganeura monni, 28 inches from wingtip to wingtip. The exact size of a modern falcon flying through air. But forget any delicate image of modern dragonflies landing on colorful flowers. Meganeura wasn't a dragonfly at all. It was Protodonata, an extinct evolutionary order that dominated the Carboniferous skies, like no other creature could then. If you saw it hunting among the canopies of giant trees, you wouldn't think insect. You'd think aerial predator. Its compound eyes contained thousands of individual lenses inside them all together. Panoramic vision of almost 360 degrees all around it, constantly. Each wing beat generated audible turbulence in the dense and heavy air. Recent biomechanical studies reveal something even more terrifying. Meganeura could carry prey of up to 2 ounces in flight. To give you a sense of that, it's equivalent to a modern eagle carrying a 7-pound rabbit whole. It patrolled territories of square miles. It hunted in the dense canopies of swamp forests. And its targets? Literally anything that flew within reach of its serrated and deadly mandibles. On the ground, another lineage of giants prospered in the ancient world. Arthropleura, 8 feet long in total. The largest terrestrial arthropod that ever existed in Earth's entire long history. It wasn't a predator at all. It fed on decaying organic matter on the ground, but its size alone functioned as living armor protection. Few predators would dare to confront a creature the length of a dangerous adult crocodile back then anyways. Oxygen allowed them to exist freely, but it didn't guarantee they'd survive forever. 305 million years ago, the balance began to crumble apart. The swamp forests that covered entire continents began to fragment into pieces. Where there was once a continuous green ocean, isolated islands of vegetation emerged. And then for the first time in the planet's history, bacteria evolved. They developed enzymes capable of decomposing lignin. Dead wood finally began to rot. The trapped carbon returned to the atmosphere as carbon dioxide gas. Oxygen began to plummet dramatically and quickly. From 35% at the Carboniferous peak to 22% in the Middle Permian period. Practically the levels you breathe today in modern air. For insects adapted to dense and superoxygenated air, this was devastating completely. Their tracheae, rigid tubes that distribute oxygen directly to the tissues, could no longer supply gigantic bodies with less gas available in impoverished air. Many disappeared in fossil layers permanently, but some resisted bravely against everything. Meganeuropsis permiana, for example. With 28 inches of wingspan, it continued hunting even in oxygen-depleted atmosphere conditions then. They were stubborn survivors indeed. Every million years, the selective pressure increased, but they still dominated the skies without any real competition among themselves, until something changed everything completely forever. Something that rewrote the rules of aerial predation forever in Earth's history. Matthew Clapham and Jared Carr from the University of California in Santa Cruz conducted a monumental study on insects. They compiled data from 10,500 fossils of flying insects, covering 320 million years of complete evolution of the group. They divided into intervals of 10 million years and measured the maximum wingspan in each geological period studied. Then, they cross-referenced these measurements with models of atmospheric oxygen over time. The first 170 million years confirmed the classical theory perfectly. Insect size followed the oxygen levels. When the gas rose, they grew. When it fell, they shrank. Perfect correlation. But something bizarre happened 150 million years ago in history. Oxygen began to rise again gradually. From 15%, it returned to 20%. Atmospheric conditions that in the past had generated flying giants. But the insects didn't grow again. On the contrary, they continued shrinking progressively. What changed on the planet then? Archaeopteryx, lithographica, the size of a crow. Asymmetric feathers, beak full of sharp teeth. It appeared about 150 million years ago in late Jurassic. Its flight was irregular, imperfect, probably incapable of long and sustained flights. But it created an evolutionary pressure that oxygen could never exert alone. Reaction speed, three-dimensional agility, pursuit capability, and abrupt maneuvers in mid-air flight. Suddenly being large ceased to be an evolutionary advantage. It became a death sentence for insects everywhere now. Giant, slow, and gliding insects became easy meals. Evolutionary fast food for the new owners of the sky. The Protodonata, which once reigned without rivals, disappeared from the geological layers, replaced by smaller, more agile and maneuverable dragonflies. The same ones you see today flying over lakes, rivers. The situation worsened drastically for them. Between 90 and 60 million years ago, a second group of aerial predators evolved, the nocturnal hunting bats. Ancestral forms like Onychonicteris, perfectly adapted for nocturnal insect hunting using echolocation. Now the giants had no refuge, not by day, not by night. John Harrison, evolutionary biologist specializing in insects, sums it up devastatingly simply. Oxygen established the physical limit of size, but winged predators became the real biological limit for the insects. The rules of evolution changed completely, and insects never again grew back to their size in the Carboniferous. End of the Triassic, 200 million years ago, atmospheric oxygen at 21%, exactly the same as today in the air we breathe. But back then, insects resembling modern grasshoppers had wingspans of 6 to 7 inches, almost 3 times larger than their current flying equivalents today. Why this brutal difference between epochs? The answer is simple and disturbing. There was still no massive diversity of birds on the planet. Predatory pressure was minimal. Insects could grow freely without fearing the dominated sky. Today, with the same atmospheric oxygen, the largest flying insects barely exceed 2.5 inches of wingspan. The difference between the two epochs? Thousands of bird species distributed across all continents. Millions of bats hunting during the entire night, everywhere, constantly. The modern sky is a permanent evolutionary minefield for large insects today. Imagine a fascinating theoretical experiment now. What if we eliminated all winged predators from the planet at once? Biomechanical studies suggest that modern insects could grow 2 to 3 times their current size without physiological problems. They wouldn't reach the impressive 28 inches of meganeura. Atmospheric oxygen simply doesn't allow that absurd size anymore. But 6-inch cockroaches? Dragonflies with 8-inch wingspans flying through the air everywhere? Perfectly plausible from a physiological standpoint. Nature doesn't allow this growth for a brutal and simple reason alone. The sky is completely occupied by predators. And they're not going anywhere soon. The collapse of giant insects wasn't caused by an apocalyptic meteor impact. It wasn't volcanic eruption. It wasn't sudden and catastrophic climate disaster either. It was something much more subtle and devastating. A domino effect of interconnected environmental changes over tens of millions of years of continuous evolution. First blow. Bacteria finally learned to decompose dead wood. Atmospheric oxygen plummeted drastically from 35% down rapidly. Second blow. Primitive birds emerged and dominated the skies. Aerial predation became absolutely lethal for any large and slow insect that couldn't escape then. Each isolated event would be survivable for some adaptable resistant insect species. But together, they formed a perfect evolutionary trap, inescapable for winged giants. Entire ecosystems don't collapse from a single simple cause. They collapse when multiple environmental pressures converge simultaneously at the same point in geological history. In that Meganeura fossil discovered in France in 1880 is engraved a truth deeper than its impressive size of 28 inches. Dominating doesn't mean being indestructible forever. Extreme adaptations, however successful, are risky. Bets when the world changes drastically, and sometimes being small is exactly what keeps you alive on Earth. If oxygen returned to 35% tomorrow, insects would grow again like before in the ancient Carboniferous period. But this time, you'd be sharing the planet with them as titans. Thank the birds that never happens. In Earth's deep past, even insects were titans dominating the ancient skies. If you were fascinated by this, journey through the forgotten hunters of the Carboniferous, subscribe here to Vittoria Extinta. Because in the next episode, we'll investigate another mass murder. The marine predator that dominated the oceans for 20 million years and disappeared in less than 100,000 years. See you then.